Hello, this is Algebra 2. We're in Chapter 8. This is Section 5, Page 1 of the notes. We're going to begin with some stuff that is relatively uncomplicated, adding and subtracting rational functions with like denominators. So at the beginning here, the denominators will be the same. This is like denominators. So basically, we're going to add or subtract the numerators. Add or subtract the numerators, then place the result over the common denominator. In our example, our letter example, a over c plus b over c, it's going to be a plus b over c. For subtracting, it's going to be a minus b over c. Keep the denominator, add or subtract the numerators. That's all. All right, here we have example 1. 9 over 6x plus 2 over 6x, and that makes 9 plus 2 over 6x, and that's 11 over 6x. That's pretty much it for example 1. So let's move on to adding or subtracting with unlike denominators. Now here we're talking about situations where the denominators are not the same. We need to find the least common denominator. This is the same as back in middle school when you were doing it with just numbers. Least common denominator, which is the least common multiple. The denominators. Then we rewrite the rational expression using the least common denominator and add or subtract. The words I don't think are actually amazing here. Notice what's going on here next to addition, right? You had c as one denominator, d as another denominator, so the new denominator will probably be c times d. It's what you need to multiply. Now, to make that happen, on the first fraction you had to multiply by d over d, and so that makes the first fraction turn into ad, and the second fraction you had to multiply by c over c, so bc over cd, and then once you're there, cd is your denominator, it was the common denominator, and then you have ad plus bc. Same thing's going on for subtraction, except there's a minus sign. So it's AD minus BC. These rules are fine. There's nothing especially awesome about them. Certainly nothing especially terrible about them, except perhaps the way they worded the first paragraph here. But even so, they're probably not particularly helpful to look at. Here's what we're going to do. We're going to stop this. We're going to go on to the next page, have some real examples with actual polynomial functions. Then you'll see. So, thank you for watching.